So first is about graph machine learning, building knowledge graphs, and then second is how it works when we combine it together with OpenAI GPT-3. And I need not, say anything about GPT-3 because that is currently talk of the town, one of the most powerful technology out there. So I hope we'll have fun learning about this today. So just quickly about me, I'm a Microsoft MVP for AI and I lead the AI IoT business for Southeast Asia region for Avanade. I am also a mentor at Code Without Barriers program Microsoft, where we routinely upskill women, women coders and welcome interns and tech enthusiasts. I'm also championing AI for sustainability for the Southeast Asia region, and you can always connect with me on my LinkedIn or on my Twitter handle, right? So before we go on to talking about graph machine learning and about OpenAI GPT-3, I just want to iterate this, important fact about why do we need graph at all, right? Because you have so much knowledge out there, you have so much data out there. You need to harness that data and get actionable insights out of that, which is why, data as we know it or data as we see it, to make it how should I say, to make it valuable, we have to mine insights out of that and make that data, convert that data or information into knowledge, right? So for knowledge mining, it's an upcoming discipline, and you see that all the language models out there, right? What we call as LLMs, large language models, like you started out with the word to vec and then BERT and then GPT-2 and now GPT-3, and in GPT-3 you have so many versions like EDA, Curie, Da Vinci. So all of these language models, what they do is to try and ingest all that huge plethora of data you have out there and gather insights or derive actionable insights out of them, right? So typically when we look at it, there are three simple steps. You ingest the data, you enrich it, right? You cleanse the data, you enrich it, you extract images out of that, or you do some language conversions, and then finally you bring it in a state where we can explore it, right? And why do we need knowledge mining? I don't think, in this day and age, I need to reiterate the importance of why do we need knowledge mining. But then, of course, we have so much unstructured data out there, right? Just data in forms of audio, video, data in form of our, journals, digital media, data in the form of unstructured information in lying in documents in our enterprises, organizations. So we need to be able to harvest that data and then analyze it, right? So as you see, there's a huge gap in this analysis. We have a lot of data, but then the ability to analyze is limited, and the data keeps on exponentially exploding, right? So we have this growing volume of unstructured data every day. And then this is what we try to do, right? So this is a very telling picture, in my opinion, that you have so many data sources out there and it just forms a classic web, a dark web, and we need to be able to mine that data and then derive insights from it, derive patterns, derive some business critical decisions. We need to unearth the story which the data has to tell us, understand the subtext, subcontext of your text, right? So one example which I really like to state in this context is, imagine in a finance domain, why this mining of data becomes so important. So you have your annual K-12 reports of companies, right? Typically they will be your summarized reports of how your company is positioned, how it is positioned to do in the future, what is the current performance of the stock, and where are the areas which it was lacking or did good, and what are some of the forecasts for the future, right? So these are classic K-12 reports of a company. Now in this K-12 reports, if you are able to harness this language models and utilize this NLP techniques, these classic knowledge mining techniques, you will be able to extract hidden insights. So no K-12 report, no company is going to put it out there saying, hey, my stock did bad this year, and then right? But let's say the large language models or this knowledge mining is trained to harness sub-context there, right? The hidden context there, saying that if your K-12 reports are saying that your stock performance was probably, not path breaking, or then it is going to be stable in the next 3 years, which means your company is not going to outdo itself as compared to this year. Hello? Guys, please mute yourselves. So your company is not going to outdo its performance, next year if the K-12 is not looking to upbeat about your company prospects, right? So these kind of unearthing hidden insights, and then being able to advise your investors or being able to make wealth management decisions is very important, right? So this is just one example. There can be lots of examples out there, and we have actually seen the ability of unearthing this kind of data potential, knowledge mining, and we have seen it being able to influence, political outcomes, election outcomes, global important implications, right? Geopolitical implications. So this is one of the examples of how we can actually, make use of the data we have in documents. Like you have signatures, you have watermarks, you have handwritten text, you have check boxes which are checked, right? So based on what kind of check boxes customer is checking, based on, certain handwritten text, we can hyper personalize or hyper segmentize certain offerings for our customers, right? The benefits of knowledge mining are, are myriad. We make knowledge searchable, we save time and money, we get insights into your data, we prevent a loss of compliance, improve decision making, and unlock advanced analytics use cases, right? So this is where it will typically come in handy: content management, analytics, feedback, customer support, compliance management, right? And if you look from an industry POV, and if you look at, top scenarios where knowledge mining is useful, it will be like, internal line of business search, where, as a user, I just want to search something within the data of my company. Now that could be inside documents, could be inside structured databases, could be inside video recordings, could be inside some confidential data filings, tax filings, but I should be able to search that data nevertheless, subject to, all the access restrictions, security restrictions. Then you have entity linking and document matching, something like, I want an amalgamated answer, so a 360 answer, which is extracted from various data sources and gives me a holistic view to my question, right? So if I'm asking about a problem, it is not only pointing me to answer to that problem, but giving me supplementary information about who has the skill sets to fix that problem, and who all, face the same problem, and so on and so forth. It could also be used as a knowledge advisor, and typically as your intelligent bot, right? Customer facing search. So let's put ourselves in the shoes of a persona. So let's say Farooq, a project planner, has a challenging project at hand, right? And then typically when he's approaching that project in a oil and gas based domain, because it is one of the most complex domains out there, he is trying to learn, and he's trying to, make his decisions based on past data or past history, right? So he has questions like, if I'm planning a project, what issues did the previous project managers face? What do they recommend? How do they solve it? And what are, equipments used? How could some equipment issue be prevented? How long did it take to fix some issues? Who are the experts? What are the spare parts available? So many questions, right? So many questions which he needs to be answered, right? So which means unstructured data has to require a holistic approach to be able to trace, trust, and monetize it. Okay, so you look at this particular diagram, and this is a real diagram. Okay, I'm not faking these contents. This is actually how a manufacturing diagram setup is out there, right? So it has diagrams, it has some tabular information, it has some notes here, probably certain safety instructions, and now, as a layman, as an end user, how do I make this knowledge searchable and make it in a way which is usable to the end user, right? So this is just a P and ID piping and instrument diagram for a fire distribution flow, right? And then very challenging to obtain the right on-time knowledge. Okay, so for example, what happens if one particular valve bursts? What happens if one particular valve is going to rust, and how do I, estimate when to replace it, or when it will be the critical time, or what will be the fatalities or monetary loss if I don't replace that, so on and so forth, right? So, and there has been proven that, in the Phillips 66 plant explosion, because of certain unmitigated and unwarranted maintenance, right? Because of, people could not foresee that what sort of fatalities or loss could happen if some spare part was not replaced or not quality checked in time. It caused release of ethylene during the maintenance of a branch line, and then that caused a lot of, damage to loss and property, which is why we have a huge demand for knowledge mining, right? And knowledge mining is not just making the data searchable, it is also about being able to link the data, which is where graph comes in, right? Graph meaning, I should be able to now understand these linkages. If I just go back, yeah, if I just go back here, so I should be able to understand these linkages, that something is a pipe has a valve is connected to something, valve has an atmospheric pressure, a double valve should have so much atmospheric pressure. So these kind of linkages between my data need to be made available to me for me to be able to understand it, right? So typically in a diagram like this, or typically in an unstructured text, if I should be able to know who are the actors, what actions do they take, and what is what are the other related entities, what are the other related actors to this, right? So when we talk of engineering use cases, right, it touches multiple areas and leverage cutting edge AI technologies. So let's say my question is, I want to know, I have a corrosion issue at some place in my pipeline, and how to repair my pipeline quickly. So this is my question, right? But my answer should be all pervading. So it should look at engineering diagrams, it should look at the documents which mention this corrosion issue. It should give me these linkages, like what is corrosion, what type of corrosion affects my particular equipment in question, what are the experts who can fix that type of corrosion, and which is where graph is a very powerful tool, right? It's not only just your normal natural language processing techniques, but a graph comes in picture. Okay, so as you can see here, right, so you will have linkages, what is an equipment, what are the different types of parts of that equipment, what are the different types of corrosion, how are they correlated to each other. So my question can give me so many different insights, and I can be able to then have a holistic view. It can give me information about production, operation, maintenance, project, Q&A, instrument, process, lesson learned, engineering. So all these are interconnected in some way or the other, and graph makes me possible to see those hidden connections, how these entities are interlinked. Because unlike structured data, unstructured data has no schema, right? So in your structured data, you have employee, department, you have a relationship between employee and department, and so on and so forth. Unstructured data, you need to construct these kind of relationships, and which is where graph is a very powerful tool which comes in picture. Right, so for graphs, typically you will need to have what we call as ontology models, which is where we define the schema. So in case of relational data, we are defining the schema in the form of tables and properties, right? But when it comes to unstructured data, we have something which is called as ontology, where we define actors, we define concepts, we define properties. So if I were to go back to that corrosion diagram, I would specify that corrosion is an entity, and then there are different types of corrosion, like a mine corrosion, brine corrosion, or pipe is an entity, right? And then pipe has properties like pipe has a diameter, pipe has a radius. So these kind of schema definitions we have to give, and then be able to unearth and be able to shape the data from our unstructured text. Okay, so this is how it will be, like the green ones you will see are the entities, right? And then these are the relationships, right? So for example, corrosion has corrosion types are atmospheric corrosion and erosion corrosion, or inspection types are liquid penetration testing, magnetic particle testing, right? And then there will be relationship between all those different entities. Okay, right. So when we talk of graphs, correct? So you have your data in unstructured format out there. you have to actually make it available into a machine readable format, and then be able to present it to end users for showing the interrelationship between your different unstructured data entities, right? So let me bring it to life. Okay, so let's say yeah, so let's say, let me go. So let us say I have this sort of a quality control rule. Okay, so if I'm talking of a vertical tank, the operating pressure is about 1000 kPa, then that pipe must have a double valve, right? So if it has a single valve, single valve, you should reject it. So this sort of an instruction has to be converted into a machine readable. This sort of an instruction has to be converted into a machine readable language, right? So when I'm trying to showcase the relationship between equipments and their connectivity, and what is a single block valve, what is a double block valve, and then finally once my graph is able to understand these kind of relationships, right? Like subject, object, and predicate. Like for example, something is located in France, or Priyanka is a person, Priyanka is a speaker. These kind of entities are relationships. Once they are identified, then we get a holistic graph, and through which so for example, this PNID diagram, which is very very mechanical, very unreadable, is then converted into a graph which is readable, right? So for example, something has a valve. This valve has these many properties, okay, and how they are interrelated. Are they directly related? Are they indirectly related? This is made available to us, right? So as you can see here, right, very very comprehensive way of showing us the interrelationships. And then these kind of instructions, then the machine can understand and immediately understand that, oh okay, if the atmospheric pressure is above 1000 kPa, then it has to have a double block valve, but since it has a single block valve, I'm rejecting this part. It should have this sort of a design, right? This is a double block valve, and because of we have the knowledge available to us, available to the algorithms, to the models in form of graph relationships, we are able to understand these kind of human instructions, apply it to the technical diagrams, and then come out with automated automated understanding as well. Okay, right? So before I go on to OpenAI now, I want to showcase you about graphs themselves, right? So how graphs work in real life, and how in an easier setting. Okay, so let me share my screen again. Bear with me, my PC is acting up a bit. So let us look at a scenario where we are making use of sorry, where we are making use of graphs, and how graphs are able to enhance our search and give us a more in detail understanding of our search itself. Okay, so let me share my screen. Mm, okay, right. Are you able to see my screen, Smita? Just let me know if my screen is
Yes,
visible.
it's visible. Yeah, it's visible.
Okay, perfect. All right. So this is a COVID search demo, and typically what it does is it brings together a data set where you have people writing about COVID medicines, about white papers where it talks about symptoms of COVID, or diagnosis or examination names, body structures which are affected by COVID, symptoms and signs, treatment names, variants, and so on and so forth, right? So let me search for something like ibuprofen. And if I search for ibuprofen, yeah, so if I search for ibuprofen, right, so it will, a normal knowledge mining would give me, documents which has a reference to ibuprofen, or which are semantically similar to ibuprofen, right? So they will give me, links to documents which are mentioning ibuprofen. But now I want to check out relationships between people who have written papers which mention ibuprofen, or people, or what are some of the diseases apart from COVID itself which are treated by ibuprofen? What are some of the side effects which ibuprofen can cause, right? So instead of hunting these down inside my documents by refining my search and then getting so many plethora of links and trying to make my way through opening each and every link to see if what I want to search is relevant or is appearing here or not, we can explore the graph relationships, right? So, like for example, if I am now searching for the relationship between ibuprofen, I have different facets on which I can search, right? So these are all the, if I'm searching contributors, then these are all the papers written by people who have mentioned ibuprofen in some or the other way. You see here, ibuprofen is my central nucleus, and then you have a relationship surrounding it. Okay, let us drill down and probably let us go to probably symptoms or signs. Okay, so symptoms or signs which are treated by ibuprofen, then you will be able to also drill down on that, right? So you will be able to see that ibuprofen is treating fever and coughing and headache and for fatigue and infection, muscle strain, and some could be direct relationship, some could be indirect relationship. So for example, ibuprofen treats muscle strain, but muscle strain is also related to fever. Okay, so you also know the primary, secondary, tertiary relationships, and you can actually see how closely connected different nodes are together, right? What is the degree of a similarity or degree of connectivity between these different nodes? So graphs in their way are very powerful. They supplement our unstructured data search and actually help us to present our unstructured data in the form of entity relationships, as you can see here, right? So all these are different documents, unstructured documents, and you are able to actually extract out these kind of defined entities and relationships from our unstructured data itself by the use of graphs. Okay, so let's further drill down and look at genes which are influenced by ibuprofen, and you can further and sorry, you can further enhance this search as well, right? So you have different gene names from different documents which are able to extract and see how they are affected by ibuprofen. Okay, and you can probably further enhance this search. So from ibuprofen I can for example type paracetamol. And then further you can again delve down in those deeper relationships, right? So you can see now journals mentioning both ibuprofen and paracetamol, and I can do the exact same graph relationships but now with a narrowed down search, right? So now I'm looking at papers where people have written about both ibuprofen and paracetamol, or I'm looking at diseases which both of these medicines treat together, something of that sort, right? So it's a powerful tool wherein we are able to convert and understand our unstructured data in a deeper context. All right. Now, where does OpenAI come here, right? So OpenAI GPT-3 and how it enables us to make this graph search easier, or just probably at a snap of our fingers, how does it enable us to be able to understand the question and then convert it into entities and relationships, right? So let me tell you how unstructured data is treated before it is turned into a knowledge graph, right? So imagine I have this unstructured data with me. It's probably a journal, right? It's probably a journal with a lot of text inside it. How do I teach it to identify entities like ibuprofen is an entity, paracetamol is an entity, or probably for example these kind of diseases, right? So these kind of body structures, right? So nose, face, organ, these are all body structures. Paracetamol, ibuprofen are medicines, or infection and pandemic pneumonia, these are the diagnosis. Then the respiratory rate, X-ray, these are examination names. So how do I teach a machine to find out these kind of entities and relationships? So I have something called as tagging, right? So I'm actually, when the text is here, I meaning, domain experts or SMEs, right? They will sit and analyze a few hundred documents. Okay, it depends on what size of corpus you are working on. So typically 50 to 100 documents, they have to sit and annotate manually. So they will manually annotate, saying, okay, they will mark this text, call it as disease entity or a medicine entity. They will mark something else, call it as, someone is not on mute. Can you mute all participants, please?
Yes, all are on mute. So I'm just checking from where exactly we are getting this noise.
Yeah. Okay. All right. So yeah, so typically SMEs, have to actually manually sit and provide these annotations, right? And typically, if imagine if documents are running around, running to about 100, 200 pages, it takes easily a few months or typically few days or months to actually sit and annotate all of these documents. Then they are fed to a machine learning algorithm, which will be then, which will understand, oh, okay, this is an entity, this is a medicine entity, this is a disease entity, this is a contributor entity, so on and so forth, and then be able to, further give us information like this from other documents, right? But it is a task nonetheless, right? That's an investment. So even though my NLP models are trained on my annotation, I need to have investment in the context of annotation tools, in the context of manpower, which I try to put in to sit and annotate these documents to actually teach it, right? So we are teaching it. Something is a medicine, something is a body part, and imagine that, in a complex system like we saw in the earlier engineering domain, where you have pipes and valves and so on and so forth, how intensive, manually, effort intensive, and how much domains specificity is introduced there to be able to sort of, annotate documents or teach the machine about parts and relationships, and then run it on other documents, and then, be able to extract insights. And after that, we still have to sit and sort of, retrain it, right? Like something, probably, let's say, it solidarity gives me as a medicine, right? Because we thought so, right? Then I have to sit and retrain it, correct its mistakes, and then put it through the NER, named entity recognition pipeline, again to further fine tune the search. Correct. So this is an effort. All right. So although it promises a lot of accuracy, and then it is enabling us to get these beautiful graphs in the end, it is an effort nonetheless. Now, till last year November, and this is from first-hand implementation which you do at client side, we were following the similar NLP approach, where we had SMEs sit and annotate documents, and then we were feeding it to natural language processing models to then, come out with the entities and relationships, and then we were displaying it into inserting into a graph database and displaying it out as knowledge graphs. Come GPT-3, because it is a large language model and can understand, instructions, right? So in what typically happens in a context like GPT-3, right? Because it is a large language model, a few instances given to it are enough for it to understand what I want. Okay, so there are some things called as zero prompt learning, multi prompt learning, one shot learning. So zero shot, one shot, multi shot learning, right? Which means if I just give it a few examples, a few prompts to show it that I want this kind of information from my documents, it will be able to do it on its by itself for the next instances. Okay, so for example, let us look at example of a graph GPT, a demo, right? So you see here, I'm specifying something called as Jerry, Kramer, Ellen, or George are friends, and I'm just clicking on generate. Okay, and then it is generating the graph, which is giving me George, Jerry, Ellen as nodes, and the relationship between them as friends. Then I'm adding more complexity. So Newman is Jerry's enemy, and but he lives in the same building as Jerry and Crown. Now I'm clicking on generate again. Then, without me being able to, actually put this data through my rigorous NLP pipelines, you are able to see that it is able to do these kind of, entities. So Newman is an enemy, but he's a neighbor to Cremor. And then I can also specify things like color something in green, color something in blue, so on and so forth, right? And then you can download this graph. So without me being able to now, to teach teach my model that, okay, Jerry, Kramer, Ellen, George are friends. So in my previous, life, or my previous year, when GPT-3 was not there, I would have to take these sentences, then annotate Jerry as a, person, Ellen as a person, and then the computer learns. Here, no need to do that, right? So it is, you see that, with a few prompts which I had given it earlier, and we will see how those prompts are given, it is able to understand and able to create a graph like this, right? So which is where some process which earlier used to take us considerable amount of time, close to around, couple of months for a few hundred documents, now has been reduced to a timeline of nearly 2 hours. All I need to do is give the GPT-3 correct prompts. So I will require some SME knowledge in the form of prompts which I'm feeding to my model, and that's it. And it's like a magic. You just give a few prompts to the GPT-3, and it is able to understand relationships and entities from all your document corpus. So it is time saving in the sense that, months are reduced to hours, and then you can be more productive, you can have more automated validations, you can have less SME interactions, you can have more accuracy, and then you have certain ideas called as prompt fine tuning, and you can choose to have different language models. So this is the power of GPT-3. Okay, so let us look at an example of GPT-3, and I'll also give you the link to this. I'll paste it in the chat window. Feel free to explore it, right? And probably, further on we can have deep dive sessions on GPT-3, where we will actually see how to write GPT-3 programs and how easy it is to write, like something which used to take about 100 200 lines of code can be easily achieved in probably 15 20 lines of code nowadays. Okay, so let us look at another popular feature, which is why graphs are used. Graphs are used for us to be able to, as I said, get a pointed answer to some particular question which is not directly available in your unstructured text corpus, right? So for example, if I'm asking a question about who can fix corrosion, or who can fix this particular sort of a compressor issue in my in my equipment, now that answer may not be directly available in my text documents. It may be available somewhere which is remotely related to one of the text document into another structured database. That is why we have graphs, where we will be able to find these kind of these kind of insights and present it to the user. So one thing which we saw was how easy it is to now generate graphs with the help of OpenAI GPT-3, right? And the second thing is, we will see how OpenAI GPT-3 can understand your document itself. So you feed it a 200-page document. It's like, it's like how we used to do a comprehension understanding in our childhood days, right? We used to be given a comprehension to read, and there used to be some question answers about that paragraph or about that chapter. Same thing. So here it's like, the computation power and the understanding is much more. So you can feed it 100, 200, 500 pages, and can ask it questions about it, and it will be able to do inferencing questions answers as well, right? So for example, this is a prompt. When I keep on saying about prompt and about zero shot learning, so this is a prompt, and the prompt is, who won the 2020 Summer Olympics in men's high jump? Currently the model has no context, right? It is just a question, and which is, I call it as zero shot, because the model doesn't have any understanding or any pre-context, and I'm just asking it a question. So question is the text which I'm passing it, and I'm asking it, who won the 2020 Summer Olympics men's high jump. Okay, and I'm using the Text DaVinci 003 model. So Text DaVinci 003 is currently the most advanced language model out there. Expensive, yes, but then it's the most comprehensive, most complete language model, large language model. So I'm using the Text DaVinci model, asking it a question, right? And then it gives me some answer saying Marcelo of Brazil won the gold medal, right? But this is not the correct answer. Marcelo is a swimmer, he is not a high jumper, right? So we know this because, of course, we have information out there. And this is something called as hallucinating. Okay, hallucinating meaning, if it doesn't know the correct answer, it will try to concoct something, typically like how human beings do, right? If we don't know something, we try to guess, we try to assume something. So this is what is called as model hallucination, right? But now I want the model to prevent hallucination. what do I do? In my old days, okay, so previously before GPT-3, we call this as model fine tuning. So I would have to actually teach the model, dude, Marcelo is the wrong answer, and actually, correct answer is XYZ, and then it would understand, oh, okay, so this we used to call it supervised learning. I used to tell it that something is wrong and just to retrain it, right? So here in the case of GPT-3, just look at the ease. My prompt is answer the question truthfully, and if you're unsure, say sorry, I don't know. This is the instruction as if I'm teaching a human personality, right? As if I'm teaching my own child that, hey, look, don't lie, and if you don't know, just say I don't know. Don't try to assume or guess something. And now with this renewed prompt, I'm asking it a question: who won the Summer Olympics high jump? Then it says sorry, I don't know, right? And now, if I want it to be able to answer the question, I am giving it a context. So now I'm giving it a context, okay, and now I'm asking the same question: who won the Summer Olympics? So this is the context, right? And then my question is so and so. What is my answer? And then it will now give me, okay, Gianmarco and Mutazessa, they emerged as joint winners of the event. Okay, so see how quickly now. Same case if I had to do it with my previous days of knowledge NLP, right? Knowledge mining and NLP, I would have had to feed this context into some indexing engine like Elasticsearch or Azure Cognitive Search, and then run the search on top of this using some semantic language models or Azure semantic search. And then if the answer is very clearly stated out there in black and white, I would have been able to get out this answer. But with the help of OpenAI GPT-3, voila, it's like, just give it a few prompts and you are able to have a contextual understanding. There are certain, shortcomings of OpenAI GPT-3 in the form of, this context. So if you think that can I feed it a context of my entire enterprise, like in this context, can I just, put all my documents which I have in my enterprise and then ask it questions? No, there is something which we call as a token limit here. There is a limit to the number of lines I can pass to my prompt for it to be able to understand the context and answer my questions, right? So for that there are other advanced mechanisms like summarization is there. There is tokenization. There is embeddings, language embeddings, and then there is amalgamation of various technologies out there like cognitive search and indexing and graph machine learning and vector databases, which will work together and then give us this answer. But nevertheless, even though we use our tools like cognitive search, or we use our tools like graph databases, with the help of GPT-3, overall the work which we need to put in to index this document, to build our language models is significantly reduced, right? And we can get more accuracy, we can get more how should I say, more productivity, and your end user is really converted to that knowledge worker, which is what we were seeking to do all this while. So not just vanilla end users, but all of us are seeking to be these knowledge workers, right? So this is what the aim of knowledge mining finally is, to turn all end users into knowledge workers. And this is what we exactly achieve with the help of GPT-3. So there are a lot of interesting aspects of GPT-3. This one is one of the very, a few ones and the easier ones which we saw. A lot of complexities, a lot of, interesting things, possibilities. So I can, within a few prompts, I can teach the GPT-3 to do wonders. It's like, reinforcement learning. So I'm teaching it with few examples. So I can teach this GPT-3 that, for example, I'm giving this context and then I'm telling it that summer 2020 Olympics is an event, or Olympic Stadium is a location, or Makim Nedasco is the name of a person, right? So on and so forth. Bronze is a type of prize or a medal. I can just teach it few things, and then you give it paragraphs, it will be able to formulate, entities and relationships. So you teach it some syntax, right? So you give this context to teach it some syntax, that Summer Olympics 2020 is an year, Summer Olympics is an event, something is a name, something is a name of a prize, something is a winner, right? Gold medal is first prize. It will be able to understand that, and once you give it additional sentences or additional paragraphs, it will be able to do this on its own. So this we call it as, this is a single shot learn. This is a context understanding, right? one-shot learning, it's like, I'm showing it one example, like this is a question, this is the answer, right? And then multi-shot learning is these are few examples, and then carry it on in the same fashion or same pattern for the rest of the instances which I feed to you. Right, so we reserve this discussion for another day and time where we deep dive into the possibilities and the intricacies of OpenAI GPT-3. So for now, I hope that you can just sit back and really soak in the power which GPT-3 gives us, especially like I told you, right? Sentences directly into knowledge graphs, sentences into RDF files, sentences probably directly into natural language to SQL. So there are a lot of possibilities, unimaginable possibilities available out there for your natural language to certain end user outcomes with the help of GPT-3, and more than welcome for you to deep dive into it on your own, or probably in our future sessions. So I'm going to also paste this link of Graph GPT in our chat window, and with that I'm ready to take any questions.